now.
Good afternoon and welcome to Callum Cymru revision sessions. This session will focus on the higher tier maths GCSE and will be presented by Mrs. Alexa Jones from Gowden School. The session will last around 45 minutes where the teacher will go through the relevant subject content. If you have any questions, please use the question and answer section and we will endeavour to answer your questions during the session. The session will be recorded with the recording and any relevant resources uploaded to the e-sgol website in the Callum Cymru area. Thank you.
Hello, today we're going to be looking at the higher tier topic of surds. I'm going to go through some examples and there'll be some questions for you to try. As this is a webinar, I will only allow a very short amount of time for you to try questions, so you might need to pause the presentation so that you've got a little bit more time to answer. Okay, so to start with, we're going to do a quick warm-up and I am going to ask you to evaluate, which means work out the answer to. So can you please work out the answer to these three, the square root of 25, the square root of 64, the square root of 36, and then can you also write down the first 10 square numbers? And I'm just going to give you a very short amount of time to do that. Okay, so I'm going to go through the answers to these. If you need more time, please pause the presentation. The square root of 25 is 5 because 5 multiplied by 5 is 25. The square root of 64 is 8 because 8 eighths are 64. And the square root of 36 is 6 because 6 sixes are 36. Now the first 10 square numbers, 1 squared is 1 times 1, 1, 2 squared, 2 times 2, 4, 3 squared, 3 times 3, 9, 4 squared is 16, then 5 squared is 25, 6 squared is 36, 7 sevens, 49, 8 eighths, 64, 9 nines, 81, and 10 tens is 100. And the reason I've asked you to write those first 10 square numbers down is because when we simplify surds, we're looking for square numbers. So we're always hunting for square numbers in order to do the simplification. Okay, so when we simplify a surd, we need to look for factors, so numbers that go into the number we've been given that are square numbers. So we are looking for square factors. And the rule that we need is that the root of A multiplied by the root of B is equal to the root of A multiplied by B. And we're going to have a quick look at how we would use that now. So I've got a couple of examples here, and the first one is simplify the root of 8, and the second one simplify the root of 75. Now, when we simplify surds, what we are looking for is we are looking for two numbers that go into factors, numbers that go into 8. And we want the first one to be a square number. So I'm looking for a square number multiplied by just any other number, but we need the first one to be square. So when I'm looking at the root of 8, I think, oh, well, 4 goes into 8 and that's a square number. So I change the root of 8 into the root of 4 multiplied by 2. So instead of 8, I've written 4 multiplied by 2. And now I use the rule to split this into two separate parts. And this becomes the root of 4 multiplied by the root of 2. But the square root of 4 is 2. So this one is 2 root 2 when I simplify it. And if you're working on these, as just practice, you can always check them on your calculator. So you can always try them first of all without a calculator. You can always check them on your calculator to make sure that you've got the right answer. So the root of 75, I would say 25 is a square number that goes into 75. So I would change that into 25 multiplied by 3. And then splitting this into two separate parts, I would say that's the root of 25 multiplied by the root of 3. And I don't need the multiplication sign in between. It wouldn't be wrong if it was there, though. The root of 25 is 5. So this becomes 5 root 3. Now, one thing to watch out for here is that the number that is underneath the root sign here, it's often a prime number. So that is often a prime number. So that's just something for you to watch out for. Okay, so here I have got some for you to do, and I'm not going to give you very long, but with these, the number under the root sign, when you finish simplifying them, the number under the root sign will often be a prime number. So if you don't come up with a prime number, check it carefully just to make sure that you've done everything right. Okay, I am going to give you just a very short amount of time to try these. Okay, I'm going to have a look at these now. If you need more time, please pause the presentation. So for the first one, 4 goes into 12. So I'm going to do the root of 4 multiplied by 3. And then I get the root of 4 multiplied by the root of 3. So this one is going to be 2 root 3. For the next one, 25 goes into 50. So I am going to do 25 multiplied by 2 instead of 50. Splitting this into its two parts, I have the root of 25 multiplied by the root of 2, and the root of 25 is 5, so this one becomes 5 root 2. Now 18, 9 goes into 18, so I'm going to do the root of 9 multiplied by 2, and that gives me root 9 multiplied by root 2. The root of 9 is 3, so this one is 3 root 2. And then 54. Now 9 goes into 54 as well. So this one's going to be the root of 9 multiplied by 6. And splitting that into its two parts, I get root 9 multiplied by the root of 6. And that one gives me 3 root 6. And if you look at the numbers here that we've got underneath the root sign, you can see that we've got prime numbers, but actually 6 isn't a prime number. But this one, it can't be simplified any further because there isn't a square number that goes into 6. So I can't simplify that any further. But it's just always worth checking if it's not a prime number, just to make sure that you've done everything you need to. Okay, let's have a look at the next part then. So we often get larger numbers, and if we get a larger number, we might need more than one step to simplify. So I've got quite a large number here, and they do tend to do this in the exam. So I've got 768. So the first thing I do when I look at this is I think, well, what square number might go into this? And I look at it and I think, well, I think 4 might go in. So I'm just going to check that. Now, this will often be on a non-calculator paper. So I am going to double check that 4 goes into 768. And 4 goes into 7 once with 3 over. 4 goes into 36 9 times, and 4 goes into 8 twice. So it does go in. It's 4 multiplied by 192. So I am going to start this by saying it's going to be the root of 4 multiplied by 192. And then I'm going to split that down, and I get the root of 4 multiplied by the root of 192. The root of 4 is 2, so I get 2 root 192. Okay, now this is partially simplified, but I haven't finished because there is actually a square number that will go into 192. Pardon me, and I think 4 might go in again, so I'm just going to check that, and I'm going to do 192 divided by 4. 4 into 1 doesn't go. 4 into 19 goes in 4 times, which is 16, so I've got 3 left over. 4 into 32 goes in 8 times, so 192 is 4 multiplied by 48. So I'm going to split this again. So I get 2, and then multiplied by the root of 4 multiplied by 48. So this is 2, and then split it into its separate parts. Root 4, root 48. And of course, the root of 4 is 2. So this is 2 multiplied by this 2, root 48. And 2 multiplied by 2 is 4. So I've now got 4 root 48. Well, looking at that, I can see a square number again, and actually the one that I can see now is I can see 16, and I can see that 16 multiplied by 3 gives me 68. If you didn't see 16, you might have needed to do 4 another twice. So this one is now going to be 4, and then the root of 16 multiplied by 3. So this gives me 4, the root of 16 multiplied by the root of 3. So this is 4 multiplied by 4, root 3. So the final answer to this one is 16 root 3. And if you look at the number here that is underneath the square root sign, that is a prime number, so I can't do anything more with it. And what you find in the exam is that some people, they will simplify them, but they won't get them down into the simplest form. So it's just always looking at it and saying, well, have I simplified this completely, or is there a square number that goes into what I've got underneath? Okay, so I've got a few of these for you to try. So can you please try these ones? And again, I'm not going to give you very long at all, and then I will go over the answers. So you might want to pause the presentation. Okay, so I'm going to go over these ones now. Let's have a look at the first one. So I've got the root of 450, 9 goes into that, so I'm going to have 9 multiplied by 50, which gives me the root of 9 multiplied by the root of 50, which is 3 root of 50. But I can see that 25 goes into 50. So with this one, I'm going to have 3 root of 25 multiplied by 2. Splitting this down again, I get 3 root 25 root 2. So this is 3 multiplied by the root of 25 is 5, and then I've got the root 2. So this one is 15 root 2. For 2000, I can see that 100 goes into that. So I'm going to start by saying, well, that's the root of 100 multiplied by 20. So that gives me the root of 100 multiplied by the root of 20. So I've now got 10 root 20. But actually 4 goes into 20. So I'm now going to say, well, that's 10. And then 20 is 4 multiplied by 5. So this is 10 root 4, root 5. And the root of 4 is 2. So it's 10 multiplied by 2, root 5. So this one is 20 root 5. And looking at these, 2 is a prime number, 5 is a prime number, so I'm quite happy that I have simplified those completely. And again, if you're working on these as revision, you can always put it into a calculator once you've done it, just to double check that you've got the right answer. Now, there will be questions where we do need to do an extra step. So let's have a look at a couple of those. The first one that I've got here is 2 root 32. So let's have a look at this one. And with this one, I am going to say, well, I'm going to leave the 2 where it is. And then 32, well, a square number that goes into 32 is 16. So this is 16 multiplied by 2. So very much as we did in the last ones, this becomes 2 root 16 root 2. And that is 2 multiplied by the root of 16 is 4 root 2. So I've got 2 multiplied by 4 is 8. So this one is 8 root 2. Now this one is slightly different. And what we're going to do with this one is we're going to use the rule that the root of A multiplied by the root of B is equal to the root of A multiplied by B. So we're kind of going to go backwards. And we're going to say with this one that we're going to start off with having the root of 5 multiplied by 15. Because as it stands, I can't simplify either of these. 5 is a prime number and there's no square number that goes into 15 other than 1, so that doesn't help us. But if I multiply them back like this, well, 5 15s is 75. So this now becomes the root of 75. And of course, there is a square number that goes into 75, and that is 25. So this becomes the root of 25 multiplied by 3. So then I've got the root of 25 multiplied by the root of 3. So this one is 5 root 3. So there's just an extra step with this one. So I've got a couple of questions like that for you to try now. So I've got 2 there. And again, I'm just going to give you a very short amount of time to try these 2 questions. Okay, so please pause the presentation if you need any more time. So this first one, now I can see that 49 goes into 98. So this is 2 root of 49 multiplied by 2. So this is 2 root of 49 root of 2. And then the root of 49 is 7. So this is 2 multiplied by 7 root of 2, which is 14 root 2. And then for the next one, I am going to multiply these back together. So I'm going to put this back in and say that I've got the root of 15 multiplied by 20, which is the root of 300. And then, of course, 100 goes into that. So that is the root of 100 multiplied by 3, which is the root of 100 multiplied by the root of 3. So this one ends up as being 10 root 3. So that's the basics of our simplifying, and that's sort of the main part that we need for the first parts of these questions. And what we might also need to do is we might need to be able to multiply out brackets. So let's have a look at those. Now, when we're multiplying out brackets, we treat them in the exact same way as we would algebra. Sorry, I'm having a little bit of trouble getting it. I'll leave it there. So what I'm going to do is I'm going to think about these as being the same as algebra to start with. And I do often think about these in the same way as I would with algebra. So let's have a look at what I mean by that. Well, Here we've got root 3, and then in the brackets, we've got 5 plus root 3. Now, if I was thinking about that in algebra, I would be thinking, well, maybe instead of the root 3, if I had an x, and inside the bracket, I had 5 plus x. So I've just replaced my root 3s with x's here to help me think about what I'm going to do. And I would multiply this out in algebra and say x multiplied by 5 is 5x. Add x multiplied by x is x squared. So this is how I would multiply out this algebraic expression with brackets in. And what we're going to do is we're going to do the exact same thing with this. And I think about it in the exact same way as algebra. So looking at this, the first thing I do is I multiply my root 3 by my 5. And in the same way, the x multiplied by 5 is 5x, the 5 comes first. The same is true of this. And we would say that root 3 multiplied by 5 is 5 root 3. And then I would multiply the root 3 by the root 3. So root 3 multiplied by root 3, I'm just writing that out like this. But I can simplify this. Now, root 3 multiplied by root 3 is just 3. So this becomes 5 root 3 add 3. And if you've got roots like this, so root 3 multiplied by root 3 is 3, root 2 multiplied by root 2 is 2, and so on. And the reason that that works, and I'll just show you why that works. The reason that that works is because when you've got root 3 multiplied by root 3, you can put that back into being the root of 3 multiplied by 3, which is the root of 9, which is 3. So this is why it works. Root 3 multiplied by root 3 is just 3. Okay, let's look at the next one. Now, with the next one, again, I'm going to think about this in terms of algebra. And if this was algebra, I might think, well, that might be 5a. And then inside the brackets, I might have 3 and it's root 2 here and then root 2 here. So maybe 3a add 4. And I'm just going to think about it as algebra and say, how would I answer this question if it was the algebra which I'm used to doing, and then apply the same rules to these. So multiplying this out, I would say 5 multiplied by 3 is 15. A multiplied by a is a squared. So 5a multiplied by 3a is 15a squared. And then I would multiply this part and say 5a multiplied by 4 is 20a. So I will now use the exact same rules to multiply this out. So the first thing I have to do is I have to multiply 5 root 2 by 3 root 2. 5 multiplied by 3 is 15 in the exact same way as it was when I did it in the algebra. And now instead of having a times a is a squared, I'm going to have root 2 multiplied by root 2. And I'm just going to write it down. Now, some of you will be able to just say, well, that's 2. 15 multiplied by 2 is 30. But I tend to write it down first, just so I don't get muddled up and then look at it and simplify it later. And then add, let's multiply these. So I've got to do 5 root 2 multiplied by 4. Well, if I had 5a multiplied by 4, I would have 20a. So if I've got 5 root 2 multiplied by 4, I've got 20 root 2. Okay, so I can now sort out the first part because root 2 multiplied by root 2, we said, is going to be 2. So this becomes 15 multiplied by 2, add 20 root 2. So this becomes 30 plus 20 root 2. And with both of these, if you were trying these at home and you were revising, and you wanted to check you got the right answer, you could actually put these into your calculator and look exactly like this, and then you could check them. And with the answer that came out, the second one, it would come out looking the exact same as this. The first one would look slightly different. And the reason that it would look slightly different is because your calculator will always put the number first. So this one on a calculator would say 3 plus 5 root 3. It would just reverse the order around to put the whole number number first. It will put the number before the 5 root 3, and that would be if you were checking it on a calculator. So it's worth just knowing that your calculator does that. Okay, so I've got a couple of those for you to try now. So can you please have a go at expanding and simplifying these? And again, I'm going to give you a very short amount of time and then we'll go through the answers. Okay, so pause the presentation if you need a little bit more time. Right, so multiplying these out. So I'm thinking about these again. If they were algebra, I would be having a brackets a plus 2. So multiplying that out, I would have a squared plus 2a. So I'm just going to apply the same rules now. So root 6 multiplied by root 6. So I've just got root 6, add multiplying root 6 by 2, I get 2 root 6. Then root 6 multiplied by root 6 is 6. So my answer for the first one is 6 plus 2 root 6. For the second one, if this was algebra, I might have 2b and then 4b minus 5. And if I was multiplying this out, I would have 8b squared minus 10b. So I'm just going to apply the same rule to this one. And I've got 2 root 3 multiplied by 4 root 3. 2 multiplied by 4 is 8. And then I've got root 3 root 3. And then multiplying 2 root 3 by minus 5, I get minus 2 5s are 10. So 10 root 3. And then just tidying this first part up, root 3 multiplied by root 3 is 3. So this becomes 8 multiplied by 3 minus 10 root 3. And that becomes 24 minus 10 root 3 on this one. Okay, so now what we're going to do is we are going to have a look at some more brackets. So I've got another couple of brackets here to expand. And again, I'm going to deal with these in the exact same way as algebra. If you can think about this in the same way as you would expand in algebra and then just look at what's happening with the numbers afterwards, that's usually a pretty good tactic to employ with these. So I'm going to think about this one as being 8 minus x brackets 8 plus x, and I'm going to think about what would happen if I expanded that. Now, some teachers have different ways of doing this. I start with saying 8 multiplied by 8 is 64, and then I do 8 multiplied by this plus x here, which is plus 8x. Then here I do minus x multiplied by 8 is minus 8x. And then minus x multiplied by plus x, that is minus x squared. Then looking at this to simplify it, I would say, well, my 8x here cancels out with my minus 8x here. So I'm left with 64 minus x squared. That's what I would do if it was algebra. Now I'm going to apply the same rules. So I start with, and I'm just going to write it down again. So I've got 8 minus root 3. And then I've got 8 plus root 3. So I'm going to start with 8 multiplied by 8, which is 64. And then 8 multiplied by plus 3, so that's plus 8 root 3. Then minus root 3 multiplied by 8, which is minus 8 root 3. And then minus root 3 multiplied by plus root 3. Minus multiplied by plus, signs of difference, so that's minus root 3 root 3. Now for some tidying up. Well, I've still got 64 here. My minus 8 root 3 and my plus 8 root 3 cancel each other out. But I've still got minus root 3, which is 3. So this becomes 64 minus 3. And the answer to this one is 61. And again, if you're doing these at home, you want to check your work, you've just got to put it into the calculator so it looks exactly like that with all the brackets, and then just check that you've got the same answer. Okay, now the other way that they sometimes do these, that sometimes confuses people, is here where we've got root 12 minus root 3 and then it's all squared. So what we're actually doing with that one is we're saying, well, what that is it is actually root 12 minus root 3, and then you're multiplying it by itself. So you're multiplying it again by root 12 minus root 3. And I always write it out with the two brackets because I find if you don't, you tend to lose the middle term. So you tend to make mistakes. So always worth writing that out. Now, if this was algebra, this might be, let's call this one A minus B, and then multiplied by itself again, A minus B. I've used different letters because I've got different numbers underneath the square root signs. So this one would give me A squared minus AB. And then here, I would say minus AB again, and I run these in alphabetical order, and that's because when we go to simplify this further, if they're in the same order, it's much easier to see what we're actually doing. And then minus B multiplied by minus B. Minus multiplied by minus is a plus, so that's plus B squared. So here I would have A squared minus 2AB plus B squared. And that is exactly what I'm going to do now with this problem. So I am going to do root 12 multiplied by root 12. So that is root 12, then root 12 multiplied by minus root 3. Positive multiplied by a negative is minus root 12, root 3. And then here, multiplying these, I'm going to do minus again. Now, it really doesn't matter if you put them in the same order or not. I'm going to do them in the same order just because I find it easier to think about them as being the same thing, but you certainly don't have to. And then here, minus multiplied by minus is plus root 3, root 3. Okay, now I've got this written out, I can try and simplify it. So I get, this is root 12 multiplied by root 12 is 12 minus. Okay, now I could just go here straight for minus 2 lots of 12 root 3. I can do that. Instead of that, I'm going to put these back together because when I put these back together and I do 12 multiplied by 3, I am going to get 12 threes are 36. And the root of 36 is 6. So looking at this, I can see that this is going to work out quite nicely into whole numbers. And then root 3 multiplied by root 3 is 3. So I've got 12 minus, and this is the root of 36. So is this one. And then I've still got to add the 3. So this gives me, well, 12 add 3 is 15. And then root of 36 is 6. So this is minus 6. And so is this one. So I'm getting 15 minus 6 minus another 6. So that one, my final answer is going to be 3. Okay. So here I've got 2 for you to try. And again, I'm just going to give you a very short amount of time to have a go at those. Okay, so let's go over these ones now. So with the first one, I am going to multiply out and I'm going to get root 6, and then root 6 multiplied by plus 2 is plus 2 root 6, and then here minus 2 multiplied by root 6 is 2 root 6, and then minus 2 multiplied by plus 2, so that's going to be minus 4. Root 6 multiplied by root 6 is 6. These cancel out, so I'm left with 6 minus 4, so my answer to this one is going to be 2. And then the second one, I am going to start by writing it out as root 2 plus root 7. And then again, I'm going to write the bracket out as being root 2 plus root 7, so I don't make mistakes. Then I get root 2 plus root 2 root 7, and then here plus root 2 root 7, and then here plus root 7 root 7. So root 2 is 2, add, and then I'm going to do the root of 2 7s, add the root of 2 7s, add, and then root 7 is 7. So this gives me 2 add 7 is 9, add, and then I've got the root of 14, add another root of 14, and actually you can add that up in the same way as if I had 9 add x, I would say that that is 9 add 2x. In the same way with this one, I would look at that and say that that is equal to 9 add 2 root 14. Okay. So the next rule that we're going to have a look at is the rule that the root of a divided by the root of b is equal to the root of a divided by b. So we can separate these out. We can start with 2 of them and put it back into 1, or we can have 1 and put it back into 2. And we're going to have a quick look at how those work. So here I am going to say, right, with this one, I am going to start by putting it back into a single root. So putting it into a single root, I would say that this is the root of 20 divided by 5. And of course, 20 divided by 5 is 4, so this becomes root 4. So the answer to this one is 2. Okay, there are 2 there for you to have a go at. So I'm just going to give you a minute to have a go at those. Okay, so pause if you need more time. Let's have a quick look at these ones. So this becomes the root of 50 divided by 10, which is root 5. And this one becomes the root of 27 divided by 3, which is the root of 9. So that one does turn into a whole number 3. Now, there's just one more type that I want to show you. And the one more type that I want to show you looks like this. So I've got the root of 18 minus the root of 6, and it's all divided by the root of 6. And what I can do with these is I can separate these into 2 parts, and I'll show you what I mean by that. So I can say that this is the same as having the root of 18 divided by the root of 6, subtract the root of 6 divided by the root of 6. The reason that I know that I can do that is because it works with fractions. So if I had something like 5 minus 2 all over 8, well, that is exactly the same as having 5/8 minus 2/8. So the answer to this would be 3/8, and the answer to this would also be 3/8. So I'm applying the rules of fractions to this. Now, with the rules of fractions then, I'm going to now go into putting these into the single square root. So this one becomes the square root of 18 divided by 6. Subtract. Now look at this one. There's a couple of ways of doing this. You can say that the root of 6 divided by the root of 6 is 1, because when you divide something by itself, you get 1. So 8 divided by 8 would be 1. X divided by x would also be 1, and that works for these square roots as well. The other thing I could do with it is I could put it back and say that it's the root of 6 divided by 6. So that's the root of 1. And of course, the root of 1 is 1, because 1 multiplied by 1 is 1. So there were a few ways I could have arrived at this. So then I would say, OK, well, 18 divided by 6 is 3. So this is the root of 3 subtract 1. And of course, if you did that on your calculator would tell you that it was -1 plus the root of 3 when you were checking this on your calculator. So that's just something to be aware of. OK, there are a couple of questions here. Now, I'm only going to be able to give you about 30 seconds to try these, but you can pause the presentation. So I'm just going to give you a little bit of time to try these two. OK, so pause the presentation if you need to, and I will just quickly go over the answers to these. So I'm going to split this into its separate parts and have root 2 divided by root 2, subtract the root of 8 divided by the root of 2, and then the root of 2 divided by 2, the root of 2 divided by the root of 2 is 1, subtract the root of 8 over 2. So this one is 1 subtract the root of 4. So that becomes 1 subtract 2. So that one actually comes out as being -1. That was the first one. And then the second one, splitting that into its separate parts, I get the root of 20 divided by the root of 5, subtract the root of 15 divided by the root of 5. Putting it back into a single one, it's the root of 20 divided by 5, subtract the root of 15 divided by 5. So this becomes root 4 minus root 3. So this one becomes 2 subtract the root of 3. OK, so let's have a little look at the things that we've covered today and the things that you need to remember. So the things that we need to remember from today, first of all, when we're multiplying. When we're multiplying, we use the rule that the root of A multiplied by the root of B is equal to the root of A multiplied by B. You have to simplify fully. So always check that number under the root sign. Is there another square number that would go in it? And if there is another square number that would divide into it, then you're going to need to keep going in order to simplify fully. If it's a prime number, you don't need to worry about it. But it won't always be a prime number, because you get things like the root of 6 and the root of 10 that can't be simplified any further. Then when we are dividing, we use the rule that the root of A divided by the root of B is equal to the root of A divided by B. So you just use this, and you might have to separate them out. And again, double check when you are dividing if you've got the same thing. So if you've got something like root 6 divided by root 6, the answer to that is going to be 1, in the same way that 8 divided by 8 is 1. And finally, when you're expanding brackets, think about them in algebra. Think about them as algebra and just do them in the exact same way as you would with algebra. Okay, thank you very much for joining us today, and I hope some of that has been useful. The resources will be uploaded to the Carlam Cymru area. Thank you.